Great. So now we're moving to what you can think is a specific class of objects which are faces that have received a lot of attention from the research community. Elisa will talk about it.
Okay, thank you. First of all, I would like also to mention that Xavi said some acknowledgements the first day, so I would also like to acknowledge Ramon Moros, Professor Ramon Moros. We are collaborating with this topic, which is face recognition, which is also another application of deep learning. And we have 2 master students and 1 bachelor student. Carlos, where is he? There. Carlos is doing his final thesis, bachelor thesis in this topic. Okay. What we treat here is not face detection, which would be very similar to what Amaya explained to you, but specifically for faces. But most people in this area use already existing face detectors, and what they do is what we call face recognition. With face recognition, we can either classify a person. That means that we get an instance of one person, and that is in our database, and we say, okay, this person is Jordi Torres or is Xavier. You decide who is this. Okay, so that's a classical classification problem. But the another problem that many people are working and using deep networks is verification. That is that okay, you get one image and you want to verify if this person is in your database, and you verify the name of the person. So I'm saying I'm Xavi Giro, and so you detect his face, and he says, okay, yeah, you're right, you're Xavi Giro. You are not an intruder, okay? Besides doing face detection, in this kind of algorithms, you sometimes do some other pre-processing. Otherwise, it's very difficult to recognize or verify who is that person, because many times you get the face which is not exactly frontal, okay? So there are also some algorithms to frontalize. So we assume that our faces are detected and frontalized, otherwise we have to do it, okay? So it's not a raw image with a face within the image, but it's quite a pre-processed face before going to the algorithm. We are also working with people recognition in videos, and there is one project here, which is Chamomile Projects, that is led by Ramon Moros, where you have also to recognize people not only using face, but also using speech, sometimes text, because you have some video shows that the name of the person is shown on the same video. Okay. So let's go into that face recognition, which includes identification and verification. And I will talk first of databases. Let's say that we are talking about supervised training and learning, so we are not unsupervised, which sometimes can be the case, but not in most of the works. And very well-known works on face recognition are DeepFace, which is the proposal by Facebook. Another one is FaceNet, which is also a proposal by another big company, that Google. So these large companies have a lot of interest in the face recognition problem. And then another work which is also quite known, which is DeepID, and is made by some people in Hong Kong. And also we do some works. It's not the same, but we also work on that area. Okay. So first of all, as I told you before, here databases are quite large. Maybe not as ImageNet with objects, but also with a lot of faces. For example, you have YouTube faces extracted from YouTube videos, of course. And for example, these are more than 500,000 pictures, more than 1,500 identities. It's been used quite a lot right now. Other popular databases are FaceScrap, Megaface for face verification. So sometimes in these databases you also have what they are called distractors. That means you have to test you have test images, and these structures have not been trained before. So you need to check also with this kind of problems in face verification. One very well-known standard is labeled faces in the wild. So it's the one that most people are using for not usually for training, but for testing. And other also now are celeb faces. And finally, we also have made a little, let's say, database with also faces. We call it Google UPC, and we use them for training of testing, and helps also for that project that I told you, Chamomile. So let's start with the proposal of Facebook. As you see, it looks like any other architecture. Maybe, let's say, one difference with respect to the networks that we have seen is that if you take one of the convolutional layers, let's say 3 or, well, let's take this one, you see here that you not only have the size of the filter, but and the number of features mapped that you have, but also there is another number, and this is because filter weights are not shared for the whole image, because a face is a very special object. Okay, let's call it object, and obviously it's not the same, the eyes and the nose and the mouth. So they use these different weights for the different locations of the image. That's something different. Okay, if we look at the classification problem, deep face treats face recognition. So this will be like for face classification. They use their own database with 4 million images, but they also use this for verification. So you need, on top of that, a verification step. And they have 2 proposals. One is for verification. If you have the output of your architecture, that of the deep face architecture, and you measure that distance. Okay, so that this distance squares divided by the sum, and you train this second step for verification, and you get some weights that will give you a correct, let's say, a correct measure to divide between. If when you verify, you have to decide, yes, it's the same person, no, it's not the same person. So you have to put a threshold and decide if these 2 persons are the same. Okay, but another proposal that they made, that is based on another work, which was presented in 2005. It's an old one, but still works pretty well. It's called a Siamese network. So like you have trained this network, this face, once, but when you get the 2 instances that you want to compare, if they are the same person or not, you like test in parallel. Okay, so you have like, that's why they are called Siamese, because they share all the ways that you have obtained. But on top of that, you add some other layers. Okay, so in this paper, they propose one way to how to manage this added layer for verification. In deep face, they use another distance. Okay, and in this case, in that top layer, so they have to obtain some parameters, and they use standard cross entropy and back propagation. Okay. Okay, this is the proposal for Facebook, since I prefer to present other methods than to give results. So the second proposal that I wanted to share with you is that the proposal by Google, and it's called FaceNet. And let's say that they propose a couple of deep architectures, but what it's important in their proposal, or it's new, let's say, it's what they call a triplet loss function. So as you see, what this triplet loss function means is like when you want to compare, this is for verification, okay? When you want to see if 2 people are the same, or the other problem is that the 2 people are different. So when you compare, your base image is called anchor, oops, And when you train, you present this anchor with positive examples, that mean they are the same person, or negative example, they are different persons. So when you learn, your process will make closer the anchors and the positives, and put the negative examples further. So you need like 3 images, or 3 examples. That is why it's called triplet. Okay, and you measure the distance. That means the distance between your anchor and your positive, plus some margin that you establish, must be lower than the distance between your anchor and the negative. That's the triplet distance. So, and then from here you define this triplet loss function, which takes into account these 2 differences and the margin. Okay. So once you have what you really train for verification is this embedding part, which takes as inputs, so the output of the deep architecture, and okay, you have the output of the deep architecture, and the embedding is this F function that you train for the triple loss. Okay, so this is another way to do it. One difficulty is how you choose these triplets. You cannot do all possible triplets in your database, and they also treat this problem in their paper. Okay, and the third system that I wanted to show is this Deep ID network. Even if it's 2014, they have proposed also some advanced architectures, but it's like the basic one is this one. It's, if you see that, it's like the architecture is typical, but they do something added on that. They say that we want to train our network for classification, but also for verification. So they decide that, okay, my parameters are these parameters that are called, as you see here, theta sub c, that is the, let's say, convolutional parameters. But they also define 2 loss functions, one which has some verification parameters that minimize this, well, should minimize this cost function, and another one which is for identification, for classification, which has some other parameters. Okay, so my parameters will be these ones, but we also set these 2 other parameters that help to define or to update the convolutional parameters. I don't pretend that you understand now this algorithm, but just for you to see that your convolutional parameters depend on some gradients that depend on the verification and identification. And let's say that you have an alpha parameter which controls what is more important, or how you balance verification and identification weights. Okay, so that's the idea. Okay, this network is trained for classification, but also, even if they take into account verification, they put an additional layer, or let's say a loss function that you have to train also for verification. And this is also a very well-known, and that now it's been used a lot, which is the joint Bayesian model. So the approach, this is for verification, as I told you, the approach is to think that one person is modeled with 2 Gaussians, one which is the first one which models one person. Every person will have a different mu distribution, so it identifies one person, but also you have the other component of this model, which models the difference between different persons, you and the other persons. Okay, so this is their model, and verification is achieved by using a log likelihood ratio. That means probability, or joint probability of 2 persons considering the interpersonal variation and also considering the inter and intrapersonal variations. And this can be, at the end, this model can be used in practice by taking, I mean, if you look at this paper, it's a long one. At the end, you end up computing some covariance matrices and getting one value. So in your training, you get these covariance matrices for the distribution of mu and epsilon, and you compute that, and also a threshold that will say, okay, if you're at the output of this John Bayesian, it's here or there, you decide they are the same person or not, okay? So these are the let's say, three approaches that are in the literature for phase identification and verification, okay? So let's go to some examples that we have done here at UPC. Last year we started working in this topic. It was also maybe a little bit naive also because we spent a lot of time trying to train from scratch an ImageNet with databases, and we didn't success. And at the end, like many persons, we finally fine-tune what is the AlexNet with ImageNet. We established which were the, let's say, how many layers we fine-tune at the end, and we got some results. Okay, and let's say these results cannot be compared because they use different databases. We tried to do something like them, but it was impossible. Like Café couldn't at that point made what they were doing in deep phase. In that other approach, Deep ID, they didn't give enough information to do exactly the same. So we did our test and we got some results, but we don't know if these results are biased by our database. Okay, but anyway, we had a first let's say classifier for persons. Okay, and this year this was the database we were used. Doesn't matter. And well, this year we are working now, so we have some results, but I will show you in the next slide. But not for this first thing that we are doing. We are doing face recognition using these very deep networks. So we are using VGG, GoogleNet, and ResNet. We fine-tune these networks. Like let's say we have VGG trained for faces and for ImageNet. But we don't have Google and ResNet trained for faces, so it's for ImageNet. So we try to combine these three networks with and doing some fine-tuning to get some results. And we are in the way, okay? We use YouTube Faces, FaceGraph, and our own database. And this is for classification, and we are also working with Carlos and Gerard with verification. Actually, this example is for classification, but we have also generated another database which combines for the training step YouTube Faces, FaceGraph, and labeled faces in the wild. And finally, this is our verification algorithm that uses VGG for faces. Then we use an auto encoder of 8 hidden layers to reduce dimensionality, and then from this size to this size, and then a joint Bayesian to decide to do the verification step. Oops, sorry. Just to finish, we need to reduce the dimensionality because joint Bayesian is using covariance matrices. So we don't want to work with, covariance matrices of 4,000 by 4,000. Again, this sorry, very sensitive. And we start having some good results. Okay, so let's say for the moment we measure precision, recall, and the F1 score, which is a mix of precision and recall. And this pair of databases, these numbers support give the number of pairs that you give to the last steps to train, okay, or to present the pairs of database to decide. And that's it.
Are there any questions for Elisa?
And well, also Carlos is working now in advanced John Bayesia, so we hope he gets some results. Okay.
Great. So let's thank Elisa for her talk.